This first question is about integration using substitution, and we're given the substitution x equals u squared plus 1. So there's two things we've got to do: change the limits and work out dx by du so that we can transform this integral from integrating with respect to x to u. So dx by du will equal 2u, and then let me deal with the units. So x, if x is u squared minus 1, then that means u squared is x minus 1, and u will then be the square root. So when x is equal to 5, u squared will be 5 minus 1, 4, square root, u is going to equal 2. And when x is 10, 10 minus 1 is 9, square root gives us 3. So I'm going to denote this as I, the integral, and I is therefore going to be the integral from u equals 2 to u equals 3 over, and actually I can replace that x minus 1 by u squared. Sometimes things cancel out, but I think it's going to be the case here, and if it does cancel out, that's okay. Let's try and get everything in terms of u. Then 3 plus 2 times the square root of u squared. And then we've got two options for what we do now. We can either replace dx by du du, write this as 2u, as we see above, or you might be somebody who makes dx the subject, then we get dx is equal to 2u du. In both cases, we get 2u du. Okay, just need to simplify this now, so I'll get rid of the limit. Well, I'll get rid of the u equals, with that's implied now. I just wanted to emphasize it because originally they're x equals limits. So I'm going to do 3 times 2u to give me 6u on the top, over u squared, 3 plus 2u, because that square root of u squared just becomes u, integrating everything with respect to u. I can cancel out the u's here, and we've got the answer required. Okay, we've got p is 2, q is 3. The rest of it is exactly the same. In an exam, I might just write out again without the, let me do it actually. Like in my final answer, I think I wouldn't just have crossed out terms in it. That's what I'm trying to say. Good, so that is this integral here. Hence, using algebraic integration, show that this integral can be written as ln a, where a is a rational constant to be found. So we're going to start with this, and we've turned it into this integral, and that's the one we're actually going to be finding. Okay, now this is a partial fractions integral from this point on, because I've got 6 divided by a factorized polynomial. It's like that's your standard thing. It's not like the derivative is at the top of the bottom. You can't do that. We just need to split this up. So in fact, I'm going to get rid of the I equals. Let's work on the partial fractions. Let 6 over u, 3 plus 2u, equivalent to a over u plus b over 3 plus 2u, split up into these separate fractions. Multiply through to give a 3 plus 2u plus bu. Substitute some values in, so 0 to get rid of the b term. That means 6 is going to equal 3a, and a is going to equal 2. And then u equals minus 3 over 2 to make the first term on the right 0. Then 6 is going to equal minus 3 over 2u. That's actually minus 1.5. You end up getting u is, sorry, not u. That should have been a b, sorry. B is minus 4. Therefore, I will equal the integral from 2 to 3 of 2 over u minus 4 over 3 plus 2u. We can integrate these directly now. 1 over u becomes ln or ln, 2 over u becomes 2 ln. The modulus sign we should put in, even though it's not going to come into play here because we're putting in positive limits. And then I've got ln 3 plus 2u, that's the main thing. This one's a little bit trickier because of the 2. So when I differentiate this back, I would times through by 2. I get 2 over 3 plus 2u. So I need to put a 2 here so that overall I get 4. Okay, that's how I would do this one. Or you can ignore the 4 and make it a half ln 3 plus 2u using reverse chain rule and then times by 4. In any case, we're going to get 2 ln 3 plus 2u. If you struggle with those, then just practice reverse chain rule, that kind of thing. You could do a substitution, but I would avoid it. I just think that's actually unnecessarily complicated. This is definitely our answer. Okay, so put in the first limit of 3. So 2 ln 3 minus 2 ln 9. Then minus 2 ln 2 minus 2 ln 7. 2 ln 3. Now they've all got a 2 in there. So your options are you could like bring the 2 up on all of them, or you can essentially factorize out the 2 and write it as ln 3 minus ln 9 minus ln 2 plus ln 7. Now we can bring the logs together. So when we're adding the logs, you end up timesing them. We're going to get ln 3 times 7. And then when we're minusing, we divide. Actually, it just becomes 3 times 7 divided by 9 times 2. If you prefer, you can do it in steps. You can add the ln and the 3 and the ln 7 to give ln 21. You can minus ln 9 minus ln 2. That's going to become minus ln 18 because we're minusing both of them. And then you can put it all together. But you can go straight to this. Just going to cancel out that 3 with the 9 partially. This leaves us 2 ln 7 over 6. We're nearly there. The final answer wanted it in form ln k. So now I will square the 7 over 6, which gives me ln 49 over 36. Okay, so substitution followed by partial fractions has allowed us to do this integral.